Welcome to today's tutorial. And in our tutorial today, we're going to look at this revision question that is coming from More Concept. And the question reads, 7.50 grams of impure zinc carbonate is reacted with excess hydrochloric acid. Write an equation for the reaction, include state symbols. Now, before we can write an equation, there is one thing that we need to take note, that whenever a carbonate react with an acid, okay, you are going to have a salt plus water and plus carbon dioxide gas. Carbon dioxide gas. So if you look at these reactants that we have, zinc carbonate and hydrochloric acid, when the zinc carbonate, okay, which is in solid state, react with hydrochloric acid, which is in aqueous state, we're going to have zinc chloride, which is a salt, plus water and plus carbon dioxide gas. Okay, so as we can see here, on the product we have got 2 hydrogen and we also have got 2 chloride. So to say to it that the equation is balanced, we're going to put a 2 here on hydrochloric acid. So in this case, our equation is balanced. We have got 1 zinc on the reactant and 1 zinc on the product. We have got 1 carbon on the reactant, 1 carbon on the product, 3 oxygen on the reactant, 3 oxygen on the product. Okay, so one other thing that we need to take note is that this carbon dioxide that is produced, it forms a white precipitate when dissolves in calcium hydroxide. So that happens to be the identity test of carbon dioxide. So we're going to say that it forms a white precipitate when dissolved in calcium hydroxide. Okay, and that white precipitate happens to be a calcium carbonate. Okay, so we can continue. So the B part of the question, we are told that 1.20 decimeter cubic of carbon dioxide is produced at room temperature and pressure. Now calculate the number of moles of carbon dioxide. Okay, so how do we find the number of moles here? So we are told that volume of a gas at room temperature and pressure is equal to N multiplied by 24 decimeter cubic. Okay, where N is the number of moles. So our volume in this case being 1.20 decimeter cubic is going to be equal to N, then 24 decimeter cubic. So since we're interested in the N, going to divide both sides by 24 decimeter cubic. Okay, 24 decimeter cubic. Okay, so what happens there is that we divide there 24 decimeter and 24 decimeter, you remain with the n. So 1.20 divide by 24 there. We're going to say that n is equal to 0.05 moles of carbon dioxide. Okay, that becomes the answer to this question. Okay, we proceed as we look at the next question. So the next question says, calculate the mass of pure zinc carbonate that would give this volume of carbon dioxide. Okay, we're saying that would give this volume of carbon dioxide. So first of all, before we can do anything there, we need to look at the mole ratio that is between carbon dioxide and zinc carbonate. So as we can see here, when there is no number on zinc carbonate, in front of zinc carbonate and carbon dioxide there, it tells us that the mole ratio is 1:1. This basically tells us that when the number of moles for zinc carbonate is 1, the number of moles also for carbon dioxide is going to be 1. Now, knowing fully well that the number of moles for carbon dioxide is 0.05, that basically tells us that the number of moles also for zinc carbonate is going to be 0.05. Okay, so we can look at this question where we can get some information where we say the number of moles, it is 0.05 moles, okay, of zinc carbonate. Okay, then what do we need? We need the molar mass. Okay, molar mass. So take note before I can explain, before I can solve the molar mass. Let me explain. So this molar mass, we're saying, is the mass of an element or a compound expressed in grams per mole. Okay, so how do we calculate this? This can be calculated by adding the mass number of the atoms or elements present in a particular what? Compound. So for example, the way it is, we've got zinc carbonate there. So we're going to say that molar mass is equal to the mass number for zinc, that is 65, plus the mass number for carbon, that is 12. Then I've got 3 oxygen there, so we're going to write 3, the mass number for oxygen, and that is 16. So this is going to be 65 plus 12 and plus 48 there when you multiply 3 times 16. So when you add 65 plus 12 plus 48, that is going to give us 125 gram per what? Per mole. Okay, so now that we have everything that we want, therefore we can say that mass of pure zinc carbonate is equal to the number of moles multiplied by the molar mass. So the number of moles being 0.05 moles multiplied by 125 gram per mole. So this is going to give us 0.05 multiplied by 125 there. We're going to have 6.25 grams. Okay, of zinc carbonate. So this is the mass of the pure zinc carbonate. Okay, so now that we have the mass of zinc carbonate, which is the pure zinc carbonate, we can now look at the last part of this question. Last part of this question is saying calculate the percentage purity of zinc carbonate in the sample. Okay, so how do we calculate this percentage purity? So percentage purity okay, is equal to mass of a pure substance over total mass of a sample, then multiply by 100. So as we can see there, the mass of a pure substance, we had 6.25 what? 6.25 grams. Now, what is the total mass of a sample? Check there, the question is saying 7.05. So we describe that as the total mass of a sample, or the mass of an impure substance. So which is 7.50 grams. Then you multiply this by 100. Okay, so when you punch on a calculator, which is 6.25 over 7.50 multiplied by 100, okay, the percentage purity there is going to be equal to 83.3%. Okay, that's a percentage purity of zinc carbonate.